What'd you do today?
Well, I put in that last welding table there. It's 11 by 5. It's actually not the final resting place. See.
Got a third welding table.
Got it all level. Doesn't move.
Yeah, it's a little dark in here.
One more to come. I got this piece over here. I'm going to turn that into an iron worker table.
So this is going to be an iron worker table
and
for
then the other
time being.
Another piece about this size for another final welding table. So the idea is to have a workflow where we've got the... See, I put it in the back for now, but that's been reassessed. So we can put the 11 by 8 table in front, so we have very easy access for large items. So we have a huge space to weld on for like CEB hopper components.
You look like Jesus.
Jesus as a homeless Jesus.
Okay, but we got to go on here. So this is the torch table that's also coming together quite well.
I think the steppers are all working now.
This is pretty amazing.
The resolution on this, like, it moves so slowly.
Yeah.
But it's got such high resolution.
Yeah, it does.
You can change that. That's what they were showing me.
Yeah. Any comments, gentlemen, on the status of the torch table here?
Just about ready to make a cut.
Are we running it tonight?
Yeah.
Okay. Good.
Yunso's birthday. It's going to be a cake right after the cut.
Okay. So that's planned in a few minutes?
A little bit.
I'm ready.
Okay. So can you describe this system briefly?
Underneath this mass of wires.
Which power supply are you using? So you got
We're using both, so we don't have enough power from one, so we had to split up the power for.
Oh, really?
One's powering two, another one's powering the other two.
So we're going to need a bigger supply.
Yes, you will.
Huh. So that's going to be even more powerful than the last torch table set, in which case we had only one power supply driving it.
Okay.
Why is it so weak right now? I was able to run 3 motors before.
At what current?
It was slow. I don't know what current it was.
Well, that's
It
probably
was
just
slow.
more current per motor right now.
So you're going to just rev it higher. More power.
More power.
More power.
So we don't, we're low on big stepper motors, and the one on the Z is not powerful enough to move it up and down, so we're not using Z at the moment, just XY.
Okay.
So we're just going to set that manually.
That thing doesn't, it's able to go across the X and Y, but not the Z?
Yeah.
That little thing just doesn't do it, eh?
No.
Okay. How about one of those, the bigger one
That'll
does do it?
Yeah.
That'll work. Okay, so did you have did you replace one of the boards?
I did replace one.
Tell us about it. So do you know what happened and what caused it?
Well, one could assume that this wiring mess shorted something out.
Uh-huh.
This will look much different. Oh, actually, no, I take that back. The problem that I think is we have a little tiny heatsink here,
Yeah.
and it's just not enough.
Okay. So
And I
just
don't have any thermal paste between the hot part and the heatsink, so
Okay.
it got too hot.
So it just got too hot.
Yeah.
So here is the stepper motor output.
That's actually power,
Oh, that's power in.
and that's step and direction.
Oh, that's step in direction
And
right
output
there.
is those four holes right there.
Yeah. Okay, hey, we get a chance here. Let's go in the light here. So discuss briefly how this thing is working here.
This is extremely simple.
Okay.
Look at it this way. This does pretty much everything.
So that's your microprocessor. What do you call that?
That
driver.
It's a driver, and there is some
It's a
logic
stepper
in it,
driver.
but it's mainly just for power. These two dip switches. For the version that you're going to get next, there's going to be one dip switch on the side, and that power connector is going away, and it's going to plug into a motherboard, 4 of them.
A motherboard that's an Arduino shield. Okay. Okay. So easier, just a little.
You don't want all this wiring. Even if you made proper wiring, it's better just to have a header and connect it in. It's more reliable.
Header, and that header is fed with power, and it's also got the Arduino signals.
Right.
Okay, so tell me a little more. A little bigger discussion.
Current is set by these current resistors.
Okay.
Right now it's set for a max of about 3 amps.
How do you set it?
There's a simple formula. It's pretty much, these are sense resistors for the current.
Mm-hmm.
And I don't
But
recall
set
the
it.
formula.
How do you physically set it?
You would have a different set of resistors for a different
Okay.
range. You can set it with dip switches for 100% current, 75% current, 50% current, and 20% current.
Mm-hmm.
But it's all, max
current-
current is
in the current
dictated by
version?
that. Yes.
Okay.
The max current is dictated by these sense resistors.
Okay.
So if you're running at 2.5 amps, I would probably set that as the max because your motors can't handle more than 2.5.
Mm-hmm.
And if you later wanted to go to 3.5 amp motors, we'd just change up the resistors.
What are the capacitors doing there?
There's not enough of them. They're there for the voltage spikes. They're just going to smooth out the power supply, and they're as close to the power pins as possible. That's where the noise source is.
Mm-hmm. And what about that little?
That's a 5-volt regulator. That'll go away as well. We're just going to run 5 volts off of the Arduino shield.
Okay. So further simplification. Wow. So we're pretty much designing this for high compatibility with Arduino boards. I mean, like simplify it to adjust.
We're designing it for you guys, whatever you guys want.
And that's, I mean, for us, we want to go with
You want Arduino.
Arduino base.
You want individual boards. That's what
Yeah.
you're getting.
Excellent. And that's usable across the board for many people because
Yes.
Arduino is well known, and this will be a system that optimizes integration with Arduino. Mm-hmm. Excellent. Yeah, good.
I
So
will
that-
note one more while I'm here. I'm
Uh-huh.
going to leave. There's a fuse right here.
Yeah.
So if they ever don't work, I would check that. And I'm leaving it soldered in because,
Which is the fuse? The green?
yes,
Okay. Uh-huh.
it's more to protect
That's for
everything
current?
else. Yes, it's more to protect everything else than it is this.
Okay. Let's see, you got your dip switches that are settable in 3 positions, or how many positions?
They're on off.
On, off, okay. Just on, off. And those little resistors there, what are they doing?
They're just pull-ups for the dip switch.
Uh-huh.
So if you turn it on, it pulls up that signal to 5 volts.
Yep. And how about like some little other resistors I see there?
That capacitor is for the oscillator for this part,
Oh, okay.
and that little tiny capacitor is further filtering for the power supply through that.
Okay, and as far as the entire pin out of the stepper controller, that's documented in its application note?
Absolutely, yeah.
Mm-hmm. And how much of it, like, as far... Okay, tell me a little bit. You did the schematic, and then you did the layout. How do you go from schematic to layout?
I'll show you. Hands dirty.